Hello all. Today we'll see the assignment number 2 that related to the single pass algorithm. So implementation of single pass algorithm or clustering. You can implement this in C++ Java. So the objective of this assignment is find internal representation for documents in a collection. That is to again to study the clustering in IR, how it is clustering is helpful in information storage and retrieval system, to search for relevant documents and various clustering algorithms. So clustering, a process of grouping set of objects into classes of similar objects. That is a cluster. Cluster. What is cluster? A cluster is an ordered list of objects which have some common characteristics. Right? So that is the clustering. Right? So clustering is the process of grouping set of objects into classes of similar objects. And when I'm saying cluster, cluster is an ordered list of objects which have some common characteristics. Right? So there are properties of clusters like intra-clusters are there, inter-clusters are there. So what are the advantages of this? Faster search is better recall. When recall, precision and recall, these are the evaluation parameters for any information storage and retrieval system. Right? So it's better recall is possible using the. Now there are, when I'm talking about this particular clustering, there are different clustering algorithms, type 1, type 2. So type 1s are like hierarchical methods and non-hierarchical methods of clustering. And type 2, the method producing exclusive clusters. That means a specific object belongs to a specific cluster. That is a single cluster. And the method producing overlapping clusters. That means some specific single object may belong to different clusters. So that type of clustering is also possible in this particular case. I hope the cluster concept is clear now. Cluster is an ordered list of objects which have some common characteristics. Right? Clustering in IR, information retrieval. So here, how we go about this clustering in IR. First, we need to find internal representation for documents in a collection. Then define clusters with cluster representative. Then you have to accept user query, find internal representation of the query. Then next step, you need to search for the relevant document. In this first level is you have to compare query and the cluster representative, and second level is you have to compare query with the actual document under consideration. And final step here in clustering IR is display resultant list of document to the user. Certain basic definitions of this here, like clusters, distance between two clusters, and similarity. So what is cluster? A cluster I already told you is an ordered list of objects which have some common characteristics. What is distance between two clusters? The distance between two clusters involves some or all elements of two clusters. The clustering method determines how the distance should be computed. Then next, similarity. What is similarity? It's a similarity measure that's a similar, say D1 or say DJ can be used to represent the similarity between the documents. That means how document D1 is similar to document DJ. That is represented using the similarity. Threshold. This is one of the important element in this particular clustering. Threshold. It's the lowest possible input value of similarity required to join two objects in one cluster. Now, for example, suppose cluster A is there, cluster B is there, and suppose I am saying that for the cluster A, suppose a particular object need to belong to required to belong to cluster A, it should have some threshold value greater than 8. That means if an object is having suppose some threshold value or similarity greater than 8, then only that particular object belongs to that particular cluster A. So such type of threshold you have to apply for the cluster. Then similarity matrix. The similarity between objects calculated by the function that is similar of di dj represented in the form of matrix that is called as the similarity matrix. That we will also see in the next slide. Then important point, seed or cluster representative. Seed or the cluster representative. The representative of the cluster, that is this, called as the cluster representative. Every incoming object similarity is compared with the cluster representative. That means that cluster representative has some similarity value associated with it, and wherever we are supposed to compare the outside object with this particular, whether the object will belong to the particular cluster or not, we are supposed to compare it with the cluster representative value. Similarity between documents. So similarity value indicates how much two documents or objects are near to each other or similar to each other. For example, the X, that is the list of index terms related to document. say document 1. Y, the list of index terms related to document 2. Right? Now this X, the number of that's absolute X, the number of index terms present in the documents, and absolute Y, that is the number of index terms present in the document. Right? And this, the intersection of two sets. So similarly, examples like X, the list of index terms related to document 1, like these are the index terms. Generally, we call these are also the keywords also. And Y, the list of index terms related to the document Y. So this X list of index terms like badge, term, pencil, like this, and the Y list is pencil, paper, cat, and so on. So this list is there. Now you can say that this is document 1, this is document 2 with these keywords, and you need to find out how document X is similar to document Y. Right? So that is the example under consideration. So there are certain matching coefficients using which you can find out the similarity between the documents. A simple matching coefficient is intersection of X and Y. Then Dice coefficient, this X intersection Y divided by X plus Y. Jaccard coefficient is there, that is in front of you. Cosine coefficient is there, overlap coefficient is there. In this matching coefficient you can find out the value. Right, so you can use the similarity function as 2 into X intersection Y divided by X plus Y, which is twice of Dice coefficient. That is also used. Now there are certain properties of clustering algorithm for information retrieval, like theoretical soundness. The clustering method should satisfy some concerns, like the method produces a clustering which is unlikely to be altered drastically when further objects are incorporated. That is, it is a stable under group. The method is stable in the sense that small errors in the description of the objects lead to small changes in clustering. The method is independent of the initial ordering of the object. Then efficiency. The method should be efficient in terms of the speed requirement and the storage requirement. Now come to the example. There are two methods that we'll see with respect to single pass clustering. This is one way. Another also will discuss that. Another method we will use for the implementation. First, to understand the concept, just focus here. So objects 1, 2, 3, 4, 5, 6 objects are there, right? So the objects are documents 1 to 6, 1 to 6, and you need to find out their similarity. How object 1 is similar to 2, 1 is similar to 3, 1 is similar to 1, and so on. So we are representing that similarity using the similarity matrix. So this is the similarity matrix. So, and their similarity values, that means object 1 is 0.5 similar to object 6, object 2 is say object 2 is 0.6 similar to 1, object 3 is 0.8 similar to 2, like this. So, and the threshold value that we are applying is 0.89. That means above this, the objects you can cluster together. That is the intention of this threshold value. Now, let's begin. Clustering method first is the exclusive clustering, and the second is the overlapping approach. So exclusive approach of clustering here, the similarity matrix is here. So process object from 1 to 6. So 1 to 6 will going to process the object. So first of all, by default, first object, that is object 1, we are putting in the cluster 1. C1 is the cluster 1. So by default, first object we are putting in the cluster 1. Then next object we are considering object 2. Then we are comparing object 2 with the available clusters. So cluster C1 with object 1 is there. So object 2 we are comparing with 1. Its similarity of object 2 with this object 1 is 0.6, which is below the threshold value of 0.89. So you are supposed to create the new cluster C2, and you have to place that particular object 2 in that particular cluster. Next, you are taking the object 3. Now, when you are processing the object 3, already there are C1 and C2 clusters are there, those you are writing, and you are comparing the similarity of this object 3 with the available clusters and their objects. So available clusters are C1 with object 1, C2 with object 2. So you are comparing 3 with 1 and 3 with 2. Both similarity is 0.6 and 0.8 respectively, which is below the threshold value of 0.89. So it does not satisfy the criteria. So you are creating the new cluster C3, and you are placing the object 3 in the cluster 3. Right? Then you are taking the next object 4 to process. Now you are comparing this object 4 with the available cluster C1, C2 and C3 with these objects inside 1, 2, 3. So we are comparing 4 with 1, 4 with 2 and 4 with 3. So when you are comparing 4 with 1, the similarity is 0.9. So which is above 0.89. So you are placing that particular cluster 1 in a cluster number 1, that is C1. That means which satisfies the criteria. So you are placing that in a 1, 4. Then again, cluster 4 is similarity with 0.9. It also satisfies. But as it's an exclusive approach, we have to place the object 4 in any one of the clusters This satisfies the criteria. So we have placed cluster 4, object 4 in the cluster C1, and we stop the process. Next, we'll consider object 5, and we'll compare this object 5 with the presently available cluster, that means these clusters. So 5 satisfies comparing with object 1, 0.9 similarity, which is above the threshold value of 0.89. So you are placing the object point 1 with inside the cluster 1, because we are compared with 1, it satisfies the value. So we are placing the object 5 inside the C1, right? And we stop the process as the exclusive object. Next, you consider object 6, and you can consider its similarity. So with the available cluster C1, C2, C3 with their objects like 1, 4, 5, and 3. So 6 with 1 not satisfy the criteria, 2 not, but 6 with 3 satisfy the criteria of threshold, that means 0.9, which is about 0.89. So we are placing this particular object 6 inside the cluster, this particular 3. So 6 is going inside this cluster 3. So we have completed the processing of all the objects and a comparison, and finally we are remain with the 3 clusters C1, C2, and C3 with these 3 objects in C1, 1 object in C2, and 2 objects inside C3. Okay. So the same exclusive approach, graphically we are representing cluster C1 with these 3 objects, cluster C2, 1 object, cluster C3, 2 objects. One important point that you have to notice, it's an exclusive approach, that means no object is repeated in the another cluster. Okay. Now in the overall approach, what will happen? Same way, you have to start with the object 1, place in the cluster C1 by default, process with the object 2, compare the similarity 1, not satisfied, create the second object, second cluster and put 2 in the inside that. 3, again you are comparing 1 and 2, but not satisfy the threshold criteria, create the third cluster C3 and place this third object in the cluster 3. Now when you process object 4, and you are comparing object 4 with C1, C2, and C3, so that means when you are comparing 4 with 1, you satisfy the criteria at 1 of threshold, and 4 also satisfy the criteria with 2 because the similarity is 0.9. Here what you are doing, you are placing the 4 in cluster C1 as well as you are placing the 4 in the cluster C2. This is overlapping approach. I hope you understand this particular difference between exclusive and overlap. Then next, you compare object 5, only one, you can say that you are supposed to compare with this particular 0.9, this particular fifth object, and is satisfied with the 1. So you are placing that particular fifth inside this particular first object, and 6 as is satisfied only the criteria with 3, you are processing with that particular 3. Okay? So in this particular fashion, you are processing that particular overlapping approach. And this overlapping method C4 is overlap with C1 and C2, that is sure. What is the significance of it? When you are using exclusive approach, that means exact data, getting the exact data for the query is very much possible. Here, percentage of relevant document will be more in case of overlapping cluster. Always remember this. So steps in single pass algorithm, like the object descriptions are processed serially. The first object becomes the cluster representative of the first cluster. Each subsequent object is matched against all cluster representative existing at its processing time. A given object is assigned to one cluster according to some condition of the matching function. If when an object is assigned to a cluster, the representative for that cluster is recomputed. So it as an object fails a certain test, becomes the cluster representative of the new cluster. That means whenever you flip that, whenever a particular object you insert in particular cluster, you need to again recompute the cluster representative value because it is going to change. Right? So you have to consider new object and then find out the cluster representative value. So these are certain steps. Advantages of this simple single pass cluster: simple for implementation, less time required for searching, and like the output depends on the sequence in which objects are handled. So this is a single pass clustering method. Now, as far as your practical is concerned, what we'll do, this particular example you have to consider for your practical implementation, right? So here, example of single clustering. Suppose that we have the following set of documents and their terms. So these are the documents and these are the terms. All of you know that in the compression algorithm, your process suppose document 1 and your output is nothing but T1, T2, T3, T4, T5 and their frequency of occurrence, that is this one. So this is the output. So whatever the output of compression algorithm, that you are considering as an input for this particular single pass algorithm in short. So documents 1 is having 5 terms, with T1 occurs 1 time in doc 1, T2 occurs 2 times in doc 1, T3 occurs 0 times, that means it is not present in doc 1, T4 is not present in doc 1, T5 is occurring 1 time in the doc 1, like this. So as for T4 occurs 5 times in document 5. So this is nothing but the document representative given to you. And now you need to find out this, you need to go for the single path cluster. Now how to start? We'll go for the term based clustering, right? We'll consider term one by one and then we'll go for the clustering. So start with T1. So we'll start with this particular term T1 in a cluster by itself, because first of all by default first term will go into the first cluster. So C1. So we'll see that this particular T1 go to into the C1 cluster. With whatever the values of T1 for this particular all the find out 13322. So 13322. This is the T1 which is by default go to the cluster 1 initially, right? Then now our duty is nothing but next consider the term T2. Consider the term T2 with this value. Then we need to find out the centroid for all the existing cluster. Now here we are going to compare this T2 with the available cluster. So available cluster is C1. So what all the values of T1 will going to compare with T2. That means we'll find out the similarity of T2, right, with the cluster C1. So we are going to use the dot product as a similarity function here. So we are multiplying this 1 with this 2 plus 3 with this 1 plus 3 with this 0. So that dot product will carry out here and we'll find out the similarity of this particular T2 with C1, that is coming 11. Right. Then again we need to recalculate that particular centroid value of C1 because it's coming 11 and here one thing you have to remember that we need to consider the threshold value. What is the threshold value that we are supposed to consider? So threshold that threshold value we have to consider here 10. So that threshold value we have considered here 10. So whatever the terms value which comes after the dot product above 10, that you have to club together in a single cluster. So here value is coming 11 which is above the threshold value of 10. So you need to put this particular term T2 inside the term C1. So when you are putting this term T2 inside this term C1, initially C1 configuration is this, it will going to change. So you need to update the centroid value of that particular C1. So how to do this? So here when you have to update the centroid value of this particular C1, so you are writing C1 is 3 by 2 plus 4 by 2, comma 3 by 2, comma 3 by 2 and 4 by 2. So that particular values you are supposed to consider here. Because why 3 by 2, 4 by 2? Remember here, this 2 means here T1 plus T2, that means 2 terms are there, that's why divided by 2 that we are considering. And here that means 1 plus 2 divided by 2, 3 plus 1 divided by 2, that's why 3, 4, 3, this upper values are coming. Remember this addition of these 2 divided by 2. Then you are updated the centroid value. Next, consider term T2 and compare with the centroid cluster C1 because only one cluster C1 is available with 2 terms right now there. But here you have to consider this particular T3 value 0, 2, 0, 0 dot product with the updated values of the centroid, that means this one. That means 0 into 3 by 2, then comma 2 into 4 by 2 and so on, plus 4 by 2, then 0 into 3 by 2 plus like this. So you will get the value 6 here, which is below the threshold. So you need to create the new cluster, that is C2, and place C3 inside the C2. So you have created the new cluster. Now consider the T4 with this value. Though you have to compare T4 with the available clusters. Total number of available clusters C1 and C2, 2 are there. So similarity of T4 with C1, similarity of T4 with C2 with the updated with their values of the centroid. So with their dot product you are carrying out. So T4 similarity with C1 coming 20.5 and T4 similarity with C2 coming 11. Both are satisfying the threshold value of 10, above the threshold value of 10. Then in the, as I told, the exclusive operator of clustering, you consider the maximum value of similarity and put that particular term in that particular cluster only. Do not repeat in the another cluster. So we are placing this particular term T4 in the C1. So when you are placing T4 in the C1, then you have to update the cluster value of this particular C1. That means you have to consider T4 value, you have to multiply it and divide by 3. You have to go for divide by 3. That means like this. You are updating C1 is equal to that T4 plus C1 values, uh, this one divided by 3. So like you are updating the cluster value. Then last cluster T5 you are considering and comparing with C1 and C2. And your first value is coming 5, second is coming 1. So both are below the threshold value of 10. So you have to form the next cluster, that is C3, and put T5 inside that. So in this way, using exclusive approach, you have formed the clusters, 3 clusters C1, C2, C3 with this object. And if you use the overlap approach, in the overlap approach, only thing is that this T4 will come in C1 as well as T4 will come inside the C2 also, and both the centered values are updated. So this is nothing but the clustering in the single pass, clustering using the single pass approach. And this you have to implement in C or C++. Thank you.